Hey everyone, and welcome back to this class, Deep Reinforcement Learning, Deep Learning in Python Part 7. In this lecture, we are going to implement a policy gradient solution in Theano for cartpole. We'll be using the same neural network architectures in this script, but a different optimization method for the policy model. If you don't want to try to code this yourself, although I highly recommend you do, the relevant file in the course repo is pgtheano.py in the subfolder cartpole. The structure of this script is exactly the same as the TensorFlow script, so it is a good exercise for just practicing your Theano coding skills. At the top, we have all the same imports as before, except we're now importing Theano instead of TensorFlow. We then have the hidden layer class. This has the same parameters as the TensorFlow version and does the same thing. There is one extra thing it does, which is saving the params. We need to do this in order to write the update expressions later. Next, we have the policy model. The constructor has the same arguments, but the inside is a little different from the TensorFlow version. Notice how we have some extra hyperparameters here. These are for RMSProp. Because we don't know how TensorFlow's optimizers are implemented, we can't replicate them exactly. Although technically you could go look at the source code, it's more interesting in this case to simply find some different hyperparameter settings. Next, we create all the layers. With Theano, we have to do the extra step of gathering all the params so that we can do gradient descent later on. And since we're using RMSProp with momentum, we also need velocities and caches for every param. Next, we create the inputs and targets, which are the states, actions, and advantages. After that, we take the log of the probabilities of these selected actions. Notice how here, unlike the TensorFlow version, we can just index the probabilities directly instead of calculating the one hot vector and multiplying. Finally, we calculate the cost, which is the same as the TensorFlow version. With Theano, we have to specify the update rule. So here are the updates for RMSProp. You can also comment that out and uncomment the pure momentum version too. Once we have all of that, we can compile the train op and the predict op. Next, we have the partial fit, predict, and sample functions. These exactly mirror the TensorFlow versions. Next, we have the value model class. This, like the other version, only uses vanilla gradient descent, so all we have is the learning rate. As usual, we create the layers, gather the params, calculate the output and cost, and specify the update rule. Once that's done, we compile the train and predict ops. Notice that because the API of the policy model and the value model is exactly the same as before, the play1 function doesn't need to change. If we scroll down to the main section, you'll notice that the only thing we need to change is remove the creation of the session, since Theano doesn't need that. So let's run this and see what we get.